And today I'm going to talk about wired interfacing of smartphone with our output circuit. So if you want to make a high pass filter or low pass filter or anything that works on AC signal, then and you don't have a function generator, so you can use this application. It's free on Play Store and it generates square waves, sine wave, it generates sine wave. But in our project we are using square wave. So let's use 1 Hertz and hook this up to our circuit. And yes, our circuit starts. And when we press the stop button here, it stops. So it's like a wired interfacing. The audio output signals are of less magnitude, so they are amplified by this interfacing circuit and provided to this output LEDs. But what's interesting to know is that how I made this interfacing circuit. So I will show you the schematic of this interfacing circuit and also show you that how its output looks like. Now I'm right now generating a square wave of 1 Hertz, and here its magnitude is 0.2 volts. So all this amplification is done by these two transistors. As it's a current operated device, BJT, I'm going to show you that how the output looks like. So we start it again. So this LED here shows you the output of the interfacing circuit, and this capacitor actually plays an important role. It not only increases the current, but it also holds the signal. So when I remove this capacitor, you can see that the on time is reduced and the pulse is also of not that much high intensity. So we'll use this, plug this capacitor again. Yes, and here our circuit has started again. I'm going to show you this interfacing circuit. So this is the interfacing circuit, and this audio jack goes to the smartphone's connector, and the audio jack actually has 3 output pins, which 2 of them are for left audio and right audio, which are the same cause we do not have channel 1 and channel 2 in our function generator, and the third pin is the ground. Now this ground pin is usually of yellow color. It's connected to this sleeve of the audio jack, so it's clearly visible. And the left and right audio pins, it doesn't matter because you have to short them and take out a wire from it through a resistance of 150 ohm. It goes to this transistor, and as we are using square wave, it turns on and turns off this transistor at the frequency of 1 Hertz. So when this transistor gets on, this capacitor of 1000 microfarad starts to charge. It starts to charge, and when the pulse is gone, it again discharges through this resistor network. Now it charges really very fast and it discharges slowly depending on this resistance value which we have set. That's why we have used this pot. Now the discharging time should be suitable for our LED meteors range shower circuit. That's why I have used a variable resistor pot. so that we can actually set which at so what is the discharge time that we want. So the signal is again given to a transistor BC557 because we want a positive supply to go to this circuit, and when the positive supply is not there, all the capacitors should discharge through this 1K resistor, which I have used just as a pull down resistor, which will pull down it to ground when signal is not present here. So yes, that's all. That's it.